happy to continue with the program. We are getting a lot of support from others also to give you a couple of classes or continuous classes for the coming 2 years. Okay. So today I will, I wanted to always connect this system to the application side. So what I want to say is, whatever we do, before we study a topic, we should know what is the application. Why we are learning this. If you are learning calculus, what is the use of calculus? Engineering. The basic maths and physics, for example. How does it come into engineering? How does it affect your approach to engineering? Is very important. Why I'm telling this is, for example, consider the structural side. In the structural side, we compute a lot of calculations. Most of you will be interested in structural and PM. That's why you have joined this topic. So if you look at the structural side or the PM, whatever, the complete civil engineering itself is actually supported by the basic sciences. That is the physics, chemistry, and mathematics. So it is high time to have a feel of all these things together. You would have studied many of the things. But if I ask you some basic questions, do you have feel of these things? That's very, very important. So I'm going to ask you one simple question. So those who knows can, raise your hand. You know how to raise your hand? In this system, you can, in the chat box, no? You can raise your
Yes,
hand.
sir.
Yeah. So I want you to answer this question, or somebody just without answering, you can just raise your hand and say the answer. I'll ask this question. What is the weight of 1 liter of water? How many of you know this? Can somebody answer this question? Just raise your hands if you know the answer. What is the weight of 1 liter of water? Good.
So Neda has raised her hand.
Yeah. Anybody else? Okay, Ashwant SR and Sajna Aziz. Okay. 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 Now, yeah, Sajna, tell me, what is the weight of
Good
1
evening,
liter of
sir.
water? Yes,
It is 1,000 gram or 1 kilogram.
correct. Very good. So it is actually, this is something we are studying in 6th standard or 7th standard. But many of you may not have a feel of this question. Because I see this, in our engineering offices. When I ask this question, they are not able to calculate the weight of, say, 5,000 liter tank. What is the weight of it? You would have calculated it during your courses and all. But still, when you ask this question directly, or, we don't have a feel of these things. This is very important. So even though you're learning something at 6th standard, it doesn't come to your help because you don't actually feel that topic and store it in your memory. You should have a feel of these things. So this is a very important thing I wanted to tell you, that you should have a feel of these things. Engineering is nothing but connecting the science. What I said about, volume and density, it's all same. how many, and let me ask you another question. Because every structure I have done, most of them, surely they are in water and soil. Because after 1 meter, it will be always water. In most of the places, in plains, only in hills, you won't see the water. So we would have learned about Archimedes' principle a long time ago. Can somebody say what is the Archimedes' principle? How many of you know? Just raise your hands. Okay, Neda knows about the Archimedes' principle. Anybody else? Anyone else knows what is Archimedes' principle? Okay, this time Neda is going to answer. Tell me.
Buoyant force
What is
will be
Archimedes'
weight
principle?
of water displaced.
Tell me loudly.
Buoyant force will be equal to the weight of water displaced of that
Buoyant force.
will be equal to the
No,
weight of water displaced.
buoyant force will be okay, but can you say in relatively simpler terms, buoyant force will be equal to the weight of the water displaced? Yeah, what Sajna says about that. Can you
So
be
when a body
simple?
is fully or partially immersed in a water, the upward force will be equal to the water displaced by that body. Weight of water.
Okay, weight of water displaced by the body. Is it true when it is floating? Is it true when it is floating? What do you say?
Yes, I think so. I'm not sure about that.
Okay, if it is a iron ball, what will happen?
It will be immersed due to its weight.
It will be immersed. So what will be the weight of the water with respect to the weight of the body? Or is it that you want to connect or something else? Density of the material is very high. I know you are telling almost correct. I'm trying to, say it in different things. So to confuse you.
So can you ask once more? I didn't get the question.
What I'm asked is what is Archimedes' principle?
Yeah,
Can you, define or tell it very simpler?
what I know is that we used to study in schools all that thing. So just a
Yeah, yeah.
principle.
Tell me. You are almost
And
correct. Only I am trying to, confuse you.
that when a body is partially or fully immersed,
Okay.
so there will be an upward force that is acting on the body,
Okay.
and that
Which
upward
will
force
be
will be equal to the weight of the body, that is the water displaced by the body, how much it sinked, or how much water,
but
the
that is
quantity of
true,
water.
not true in the case of a iron ball, no. Weight of iron ball will be much more than the weight of the water displaced. Is it not?
Sir, it is something related to center of gravity.
No, it's not at all connected with center of gravity. Okay, but when you started with the 9, it was like a definition, whether it is by-hearted or you understood correctly, that's why your definition was correct, that the buoyant force is exactly, buoyant force is the weight of the water displaced is correct. But whether you understood it or not, it was my question, whether you can apply it to an application or, one case. That was my thing. So when I asked about, the iron ball immersed in that, there also it is same, the weight of the water displaced and the buoyant force is correct, but it's not connected to the weight of the body. So I just wanted to confuse you, but you said the definition correctly, but I just wanted to know whether you know it in the application side. Why I'm very particular, why I asked all these things is, what happens in the real-time scenario? For example, in a basement kind of a building, there is a buoyant force we get when it is a fully submerged place. When we build in Cochin, area like Cochin, the whole of the structure is actually immersed in water. So there will be buoyant force we are getting to the building. We can utilize in the construction. Some of the malls in Kochi is constructed without considering this buoyant forces, which can, actually reduce the weight of the building, because the water is acting upwards, especially in the true of, double basement and all. So when you counter this value in the pile design, the net loading required for the pile design, you are actually saving 1 or 2 crores of rupees in the pile design. So learning Archimedes and finding it exactly and applying it in the exact situations is very, very important. That maybe even out of consultants, people are not able to understand it correctly. Okay, so I'm just talking to you as if I'm talking to friends, not through a class-wise system, like a presentation and graphics and all. So what I want you to, actually venture into this, look at some practical applications and make a feel of these things. So that's very important. Okay. So this is what, a message I wanted to give you today. And all over the, course, it is not very difficult because these are all small things we learn at the very small classes, civil engineering is mostly it's common sense, common science and common sense. It is important that you should have the common science also into our calculations. Okay. Now, what are the things we are concentrating on? Structural, project management, geotechnical, and how to build all these things together. This is a challenge. We have taken it. I actually practiced as a structural consultant. Then, we tried to build all these separate streams together through a software network. You are, all accustomed to different softwares, use of the softwares, different softwares, not in science, civil engineering side, but, we use softwares for booking a ticket, booking, a room, hotel, all this, you're familiar by doing, all these small applications. So think it in the same way. It's all same applications connected together in one platform. So it may be an estimation tool, it may be a planning tool. All these are connected together, and all of this, it's nothing very different. It is just the things you actually do. It is all connected together. So we are taking you to such an environment. So we will be giving you some classes here and there for you to, accustom to different things. So first, we don't want to, take you exactly through a structured way, but we want to just show you some of the possible things or interesting things, some of the areas where we have used AI, to do things differently. Some of the things, you can read it, the way you can improve your work. Let me tell about one or two applications I have told earlier. So today, Rindu will be showing you one very interesting application. That is something which it stuck to our minds earlier. So if you have a 2D drawing done by the architect or anybody, then why don't a system understand this from the 2D and they create the 3D by itself? So we first did with the estimation tool. So estimation, the AI, the artificial intelligence has to understand the building and then they estimate. Okay. So once it was done, we did the same tools. We used the same things to image. So to post it to a 3D image, we selected Revit. So what happened? We combined these two things together and it will do the estimation. And once the estimation is completed, it will also give you 3D. Okay, so, this is the way the softwares can work. The AI can work for you in the future. It can, really do things differently, much faster. And all of this has an economical quality and structural quality, construction quality, all enabled by the systems. So seeing all these things will be interesting. It is going to make you much, much powerful, much, much powerful. In olden days, you can say, I will be doing structural. Some people will say, I'll do geotechnical. I don't say this anymore. With IT, with knowledge information, with everything, you can do actually everything now. You can be a good all-rounder because you have the resources. You can do much faster. You can think faster. You can make these things faster. So this is the idea. I just wanted to, motivate you by telling some of the things. There are hundreds of things we have to talk to you. Even 50 or 60 modules are there. The interconnection, permutation, combinations of these 50 modules will be thousands and thousands of things. Okay, so with these words, I wind up for the day. If anybody has questions, you can ask me. Okay, the second part will be taken by who's going to present now?
Sir, it's me, Rintu.
Yeah, okay. So Rindu will, I'm handing over to Rindu. Thank you.
Thank you, sir. Just let me know when my screen is visible.
Yes, yes.
It's visible. Please continue. Thank you. Now, isn't it possible to construct a building just by having the 2D drawing? If you think so, it is possible. It's not that it's not possible without the help of a 3D model. But what is the advantage of using a 3D model? Like, for an example, there is a column which is provided by the architect. And the structure engineer wants to move it to another place in order to balance the loads. And how can it be visualized that the moving of the column will not affect the aesthetics? Or in the reverse way, the structure designer wants to insert a column and the architect is concerned about the aesthetics. In these both cases, both of them can depend on a 3D model. Like rather than looking into 2D drawing and wondering what will be the situation, we can actually see into a 3D model and understand what is going to happen and how can we solve this issue without affecting the aesthetics or the structure stability. So that is where the importance of 3D modeling comes in. Now there are various, like numerous softwares available currently, which is based on 3D modeling, 2D drawing, drafting and all. And one of them is Revit. Why Revit? Revit is a higher precision software and is capable of more than 3D modeling. It is more of a BIM based software. Okay, I'm not going into that details because that's a huge topic to cover on. Now let's see how we are linking a 2D drawing into a 3D model. Now it involves 4 steps. The first step is drafting. The basic drafting, we are starting with a 2D drawing. Now first we have to prepare an AutoCAD drawing. And in the drawing, you have to make sure that each element is in a layer. What do you mean by a layer? A layer is just simply denoting that something is having a similar property. Like walls can be grouped, and that group can be called a wall layer. Similarly, you can group the beams and put in a layer. That line which is used to draw a wall or a beam will be given a different color, a layer name, etc. in order to identify what that element represents. So in the background, you can see a drawing wherein different colors are given. So it means that either these two elements have a similar property. Maybe these beams have the same property. Here we have walls, we have other writing texts. All these can be identified by using different layers. So you have to make sure that you are using proper layers. Now, then you have to make sure that you are including the beam column layout. This is necessary when you are estimating or dealing with a framed structure. What is a frame structure? What is a load bearing structure? A frame structure will have beam column in addition to the walls. And a load bearing structure will not have as much as beams and columns involved as a fully framed structure. And in the load bearing case, the load will be completely or partially taken by the wall. Okay, now the details of this, you can Google it out. For time being, just understand that a framed building is like a skeleton, which has beams and columns and slab. And the wall is just a partition in between. Whereas in the load bearing, the load is also carried by the wall. Then the step 2, scanning. Scanning is done in Estimax. Estimax is, in simple terms, it is a software used for preparing estimation. If the term estimation is new to you, just understand that estimate or an estimation is a process wherein you prepare a report which contains the quantity of material and the rate of those materials or labor or whatever resources that is involved in the construction of a building. Okay, now preparing an estimate will help you to understand whether you can complete the building within a time span, within the budget, and how can you adjust your resources in order to complete it. Okay, it is much related to the planning of construction also. Now in Estimax, what we do is that we will scan the AutoCAD drawing and produce a Estimax file, that is a estimation. And then we'll upload this in ERP, which will be the step 3. In ERP, you might have noticed this in the last session. There is an option for uploading Estimax file in the Masters tab. So therein you can upload an